This is slide 25 to 29, where we're using the ratio so the thermochemical equations where you've got change in H, or you've got a certain kilojoules per mole given to you, and then we want to find the energy for a reaction with the different numbers of moles. So we're just using our relationship, either if you've got a whole complete reaction where you know the kilojoules and whatever this number is, in this case it's 1 mole, or if you're looking up the data booklet and you've got a certain number of kilojoules per 1 mole, it'll be for 1 mole in the data booklet, but not necessarily 1 mole in a thermochemical equation. So we're relating the moles to the kilojoules. So cellular respiration, what is cellular respiration? It's a process in the cells where glucose is broken down to produce energy for the cell. The difference between aerobic and anaerobic: aerobic uses oxygen and produces the most energy. Anaerobic happens when there's not enough oxygen. So if you hold your breath or you're running really quickly, you get anaerobic respiration happening. You still can make some energy, but it's a lot less than aerobic. So as far as chemistry is concerned, aerobic, when you've got a lot of oxygen, is also called complete oxidation. What's the balanced equation for a complete oxidation of glucose? So this is in your data booklet. Glucose, no, it's not, but it could be given to you. This could be given to you. So 1 glucose molecule will make 2,860 kilojoules per 1 mole. So anaerobic respiration, in humans, we can break down our glucose if we don't have enough oxygen and form lactate ions. So when your muscles are sore, you've made these rather than complete oxidation. So you've still got carbon-carbon bonds, carbon-hydrogen bonds, and you only get a small amount of energy released. We need to know this next equation. So in yeast, anaerobic respiration for glucose makes ethanol or bioethanol. So this is our fermentation reaction to make bioethanol. So you need to know that it's a 2 of these to every 2 of those. So just remember when you're balancing it, you've got 2 here. So if you double it, you've got 4, and you'd only have 2 carbon dioxides produced, and you only get a small amount of energy released. So aerobic produces more energy, but anaerobic can be faster, and it's good if you don't have enough oxygen. So aerobic, because it's completely oxidized, your carbon is now at its lowest oxidation number when it's in the form of carbon dioxide. So if we looked at working out the oxidation number, it would be -2, -4 would be +4 for carbon. So the most oxidized. All right, we want to be able to use if you're given a thermochemical equation or the change in H, we want to use our ratios. So I don't like you using the E equals change in H times number of moles, because it's just another equation to remember. Just use the ratio. So if you've got these 2 reactions, which one produces more energy? Your body respiring 10 grams of glucose, so this one, or yeast fermenting 300 grams of glucose. So we've got a lot more glucose here, but a lot less energy. So we need to work it out. How much energy is theoretically produced by each if there was complete, these reactions went to completion. So we need to turn our masses into moles in order to relate, these are both a 1-to-1, in order to relate the amount of kilojoules for 1 mole, we need to work out the number of kilojoules for a number of moles that we're given. So we need to turn the 10 grams into 0.056 moles and then relate that to the 2,860. So how much energy if you have that many moles? when we know that 2,860 kilojoules is produced from 1 mole of glucose. So our ratio, the moles cancel and you're left with the amount of kilojoules for aerobic respiration. So 159 for the first one. Do the same thing for the second one. And you see it's 115. So the 300 grams is pretty close, but it's still less than the 10 grams. So this is what we want. Remember what we want, what we've got. So what we've got. And these are the relationship. We know that 69 kilojoules is produced for every 1 mole. So just remember to set it up. This is what we want. This is how what we know how they go together. This is what we want. This is what we've got. And then if you take that over and write your units, and it should be easy. People get these things mixed up too often.